Hey, what's going on? I just wanted to showcase a new approach found by Security Joe's, which is a new twist on the classic DLL search order hijacking. Ordinarily, this technique would be delivered to the victim as a phishing law, where the victim would be served a zip file or an ISO file containing a legitimate signed binary, often a Windows binary or any other kind of trusted executable. With a DLL, which is going to take advantage and exploit the weakness of search order hijacking within this executable that it's sent with. So the actual technique of search order hijacking takes advantage of executables which do not specify the full path to the DLL they require. And as such, Windows will perform a search in a predefined manner as to where to look for the DLL. So as Security Joe says here, the executable will first search the directory from which the application is launched, then see Windows System 32, see Windows System, see Windows current working directory, directories in the path, sorry, the system path, and directories in the user's path. So the difference with this new approach is twofold. The first is stealthier execution. So unlike typical DLL hijacking that may require additional binaries or higher privileges, this allows the execution of the malicious code within applications located in the Windows folder without those requirements. It provides a more subtle and stealthy method of exploitation. And the second is the simplification of the attack chain. So by leveraging a vulnerable executable already present within the Windows folder, specifically these binaries are within, so C Windows, and then it's this WinSxS. Where are we? WinSxS. So there's binaries in here that it exploits. It eliminates the need to drop vulnerable application, simplifying the infection chain significantly. It also reduces the footprint of the attack, and it's incredibly stealthy, which is pretty cool. So let's take a look at how we're going to be taking advantage of this. I've actually built a reflective DLL injector. It's built in C, which will take a DLL loaded into memory, so whether that's hard coded or downloaded on the fly, and inject the raw binary data into another process running within Windows. This is quite an advanced malware injection technique, but in short, there are many advantages to doing reflective injection. Most notably, the actual payload can be positioned in such a way that it's never stored on disk, so it's existing only in memory. Most importantly, I've built the injector in such a way that it can be built as either an executable or as DLL, which we'll be using in this example. This wouldn't work with the injector being an executable. So before we launch the attack, let's take a quick look at the reflective loader I've built. As I've said, I've built it as a DLL so we can use it in search order hijacking. So I've loaded it into PEBear here, and you can see the various section sizes over here on the right hand side. To keep this simple, we don't use any advanced packing, encryption, or obfuscation of this portable executable. So to quickly explain the different sections of a portable executable file, if you've never come across them before, we have the text, the .text section, which is basically the meat of the executable. This is where all the actual executable code and instructions are. That's these here. We have the .data section, which stores initialized data. We have our data, which is it stores read-only and constant data, so any constants that you set in the code. You also have things like the BSS, which is where the statically allocated variables live that have been declared but not assigned a value. Now, what's interesting about this is to build this reflective injector, I've read the DLL binary straight into a C header file, so it's baked into the portable executable, so into this final DLL, and it'll be read into memory rather than read from the disk, as is kind of the point with reflective injection. So you can see here, if we have a look at the .data section, it starts here. So this here is kind of like the different sections of the reflective injector, the portable executable. And you can see this yellow bar here is all the .data section. Now in a normal, relatively small executable, you'd expect this data section to be quite small. with the text section being the biggest, ordinarily speaking. But here, quite interestingly, if you were to lift this yellow bar out and sort of whack the rest of these sections together, they'd both probably come out about the same size. And there's a reason for that. That's because when we've loaded our DLL, our sort of implant malicious DLL, into our injector, this is where it's hidden. So you can see here these magic bytes, the MZ4D5A, that's the start of the implant DLL, if you like, the actual malware within the bigger binary, if that kind of makes sense. You can compare that to the .text section, which is tiny by comparison. Okay, so let's get into it. As per the research by security Joes, we're going to take advantage of a binary called ngentask.exe, which is located in the Windows WinSxS folder, which searches for a DLL called mscore service.dll. So as this DLL isn't hard-coded within the binary, we can put a DLL by this name in the current working directory, which the code is going to be working from, and then launch the executable within the Windows folder from that directory, which we're going to show you. So let's have a quick look at the execution flow. Essentially what's going to happen is the victim is going to receive this zip folder here called totally safe, which contains a couple of things. So the first thing to note, obviously this first one here is a shortcut. Within this shortcut, we're actually launching a batch file, which is this script.bat, which I've got open here. And that's, we're going to have a look at that now. So this script, basically all we're going to do, nice and simple, is open up a decoy file, which is bud3. We're going to set a variable for the malicious directory, which is going to be in app data, and we're going to call it Windows Copilot add telemetry. It's kind of relevant to sort of modern stuff. You might not question that. We're going to make that directory. We're going to curl down the malicious DLL from our C2. So I've built a very, very basic command and control server, which is here. It really is basic. It's basically listening on /SOH, which will serve this file, which is obviously located on the server, and send it to the victim or whoever's making the request. So going back to here. So we make the curl, check that there was no errors. If there was, clean up and exit. If the file doesn't exist, again, exit and remove any indicators. So this is kind of where the important stuff happens. So by this point, we've downloaded the file. All is good. It's in our malicious directory, which is in app data. So what we're going to do now with the batch file is we're going to change directory to the malicious directory. So it's currently our working directory. And from there, so from that directory where we've got this malicious DLL, we're going to start ngentask.exe, which is the Windows binary, which is vulnerable to exploitation. So what that's going to do is, because of this DLL Search Order Hijacking, it's going to load our reflective injector, which you can see part of the code for here. So as we've built it as a DLL, basically it's going to load this DLL main function, and because we're just sort of testing this, we're going to hard code in the process that we want to inject it into, which in this case is Notepad. Normally you'd use something like a Windows process like Explorer, something which is definitely going to be open. And basically when the DLL attaches to a process, we're going to actually kick off the launch, the reflective processes down here, which is where we actually do the reflective injection. And that's going to inject our malicious payload, if you like, our implant, which is this, I've built it in Rust. It's just a basic DLL which pops open a message box using the Windows API and says hello from Rust, which is pretty cool. And again, you can see here we've got the DLL process attached in a match case. Okay, so here we are in the C2. Let's go ahead and start that up. Now you can see here that we do have the DLL
waiting to be served, so that's going to be served over HTTP when we make a GET request or a request to SOH. Now let's just quickly go and have a look in the app data folder. So this is where our malicious batch script is going to write the DLL2. So if we quickly, just to go and sense check this, let's go and open command prompt from here and let's grab that Windows binary. Here we go. So let's copy that. And if we run that right now, hey, look, nothing's going to happen. In fact, just to prove the point, because we're going to be injecting into Notepad, let's open Notepad up and let's just run that binary again. Wonderful, nothing happens. There's no pop-up. So remember, we are expecting to see a Windows pop-up come up, a message box, if the DLL gets successfully injected into Notepad. So let's close this down and let's go ahead and be the victim now. So we received this phishing file and we're going to go ahead and click this shortcut. And you know what? Let's just see what happens. So in fact, let's move this over here. So here's our decoy document that's popped up. And here you can see, hello from Rust. Hey, Rust attached, which is the message we were expecting. So that means that our malicious DLL, our implant, has injected itself into the process, the memory space of Notepad. So that's fantastic. Let's just go and have a quick look in the app data so we can see now that we do have this new folder created that we have specified up here. Look, Windows Copilot add telemetry, and here is our malicious DLL. So all that's happened is from this location here, this executable, this binary has been executed. So if we go ahead and close this, in fact, it doesn't really matter. We can we don't need to necessarily close that with reflective injection. So let's go ahead and open up that executable again from this path, and what we should see is another pop-up. And we can do that again, and again, and again, and again, and again, and again, and again. Now the cool thing is, if we go up one directory and we do it again, you won't see another pop-up because remember the exploit. It's not really an exploit; it's more of just a general weakness, vulnerability, whatever you want to call it. Will only work if we are in the current directory where our malicious DLL is. So that's wonderful. We can obviously close other windows. We can do lots of things. However, as soon as the parent process gets terminated, you'll see that all of our implants disappear. And that's because they're all living in the memory space of another process. So in reality, in a real red team engagement, what you'd be looking to do is do this within maybe something like explorer.exe or any of the Windows services that are really going to be open for the full duration of the user's session. So there we have it. Our implant was running in the memory space of another process which doesn't need to touch the disk, or from clicking a single file. All of this happens, of course, when a DLL is downloaded and a legitimate Windows binary is executed. So, what could be malicious about that, right? Well, we've just shown quite a lot.